So, good afternoon, everybody. So, people who are joining online, so I see how many are you there. So, I see 22 are there, and 8 people are here in face to face. Actually, I wish more people will join, and everybody will make this classroom collaborative and cooperative. Okay. So, people who are joining online, so if there is no background sound, background noise from your side, you can keep you unmuted. Okay. But if there is any background noise, so then please make yourself muted. Okay. Can you hear me? So who can I talk? So Abia, I see Abia Rahman. Can you hear me?
Yes, I can hear you.
Okay, thank you. So then you can, so yeah, everybody please speak aloud whenever you have any question, okay? Okay, don't hesitate and feel free to ask me and stop me, okay? So at this point, so let us start our lecture, and as usual, so let us see our schedule. Okay, so according to our schedule, we are on week 7, right? And this week we will cover module 5, one-dimensional array searching and sorting algorithms. Okay, and there will be quiz 5 due on October 4th. Okay, so if we go to our slide, so this is the module 5, searching and sorting algorithm slide. Okay, so I do have already downloaded it, so I'm not going to download. So if you remember in our last lecture, I discussed how to write a program that will help us to search a target element from an array, one-dimensional array or a list. Okay, so today I will review that is called linear search algorithm we discussed, and I will go through a binary search algorithm, and I will discuss this with some live programs. Okay, so searching algorithm is widely used in computing. So you need to have a clear understanding of searching algorithm. Okay, so that there are many searching algorithms, but these two are widely used. Number 1 is called linear search algorithm, and number 2 is binary search algorithm. Okay, so linear search algorithm, linear means sequential, okay, or serial. In a linear search algorithm, we started from the beginning of an array and we go one by one element until we find our target element, or we go all the way end of the list in order to declare that there is no such element. It may happen that we may find our target element at the beginning of our search, or it may happen at middle of any point, or it may exist all the way end, or in the worst case, it may not exist. So if it exists all the way end, or if it does not exist, so in both cases, we need to search all elements, right? So the maximum visits n, where n is the size of the array. Okay, so whenever you take your algorithm course or data structure course, then you will learn that we measure the efficiency of an algorithm by measuring. So there are some ways like big O notation. Okay, big O notation, that means in the worst case, how many searches it needs. Okay, so it says big O(n), that means in the worst case, a linear search algorithm takes n, or that means it goes to all the way end, all up to n elements. Okay, so you will learn later what is called by big O(n) or big omega. Okay, but if this is an array, G is a list or array, and I have a target variable, and we say is in list. This is we call this variable. We call this as a flag. Initially, we start with a flag is false, and if we find any match in the list as our target value, then we make the is in list true. Otherwise, it remains false. So this is the algorithm for a linear search algorithm pseudocode format, and in program code format, Java format will be like this. Okay, and C# a little bit change. In C# instead of boolean, we will need to bool. Okay, so in C# like this. Okay, and elements in the list. So this is why we say that in the worst case that it takes all elements. Is efficiency is big O(n). Okay, so in this is C# program code. In Java and C#, there is a built-in field for all array. Is called length. In Java, it is L in lowercase, and in C# L in uppercase. Okay, so this length attribute is used to find the length or size of an array. Okay, but in C++ there is no such attribute. You need to find out. There is another way. You need to find out the size or length of the array. We will go there soon. Okay. So, has anyone any questions so far? In our last lecture, we discussed until this. Okay, so if we go to our code, and then this is the code implementation of actually this part. Okay, is the implementation of this part. Okay, so I will discuss this implementation in all three languages: C#, Java, and C++. Let's start with C#. So if you go to my Replit account and search for linear search, this is the search. Linear search example 1 C# program. So you see that this is, for instance, this is the code for linear search algorithm. Okay, so let us go through this. So here my data is a list, right? Or an array is one-dimensional array. Okay, what is the length or size of my data? So 1, 2, 3, 4, 5, 6, 7 elements, right? It has 7 elements. The length is 7. So how can we find the length? We do not need to manually count size. So if we count manually, then we would write 7 over here. Okay, but at this point, say if we delete an element, your program will make an error. So in order to resolve this problem, this kind of issue, there is a built-in field, it's called length, L is in uppercase. It will help us to find out the length automatically. Okay, so then what we are doing, for instance, from this array, we want to check whether our target value 5 exists or not. So we say integer target equal to 5, any element we can check for. And then initially we say bool equal to false. And we say count, integer count equal to 0. Initially we assume that there is no such element. So So we can use, there are multiple ways, there are at least two ways that we will discuss. We can use a flag, this is a flag, also this is a flag or counter. We can use a Boolean flag variable as flag, or we can use a like counter variable, counter 0. Anyone we can use, or we can use both. So here I have used both. So how did I use that? Please see the code. So we are, for this loop, I am looping through all the elements, traversing all the elements in the array. So then if I say if my data I, right, I start from 0 and it goes to all elements. So that this is the last. So you say less than, that means the last element, it will go through the last element in the array, last index in the array. So if we say my data I, this is I for index, it will change equal target. If I find my data, for instance 5, it matches with any element. So this is the code how to find that, how to do that check. Then what I will do, I will make my flag as true. Initially it was false, right? And then I will make it, when I find a match, then I will make it true. And moreover, I can increment my count. How do we increment our count? We say count plus equal 1, right? This is equivalent to count equal to count plus 1, or we can say it count plus plus. All these three lines are equivalent, whatever you write. Or you can say plus plus count. That will do. So here now, if there is a match, then our flag will be true. If there is no match, then our flag will be false. So here in code, usually we write if so there are multiple ways here we can do, right? So you say if flag equal to false, right? That means if flag equal to true, right? So then if flag not equal to false, that means if there is a found, then we can say the number target is found, and it says how many times. Count will say how many times. Else, that means if flag equal to false, then it will execute this statement. Okay, now if we run this code, then in our list we are searching for 5, right? So how many times 5 exists? 1 time. If we change another value 51 to 5, and if we rerun this program, it will say number 5 is found 2 times. That means this program works, right? And if we search for -5, there is no -5 here. So then it goes to this, the number -5 is not found. But if we search for -3, then it will do us -3 is 1 time, right? Okay. So this is the implementation of linear search algorithm. So this code is written in C#. You see the C# code, and in C++ you need to make a little change. Sorry, in Java you need to make a little change. Bool you need to change this to Boolean, and here console.writeLine you need to make it system.out.println. Okay. And one more change here, length in Java L is in lowercase. So in my Replit account, I have this program both in Java and C++ format. So this is This is Java. This is C#. So if you search for C#, and then I need to, if I go for Java, I should get the Java program. So the same code is in Java here, okay? So what I'm doing over here, so in simple code, you will see that if flag. Okay, what is meant by if flag? If flag. That means you will see sometime over here, that means if flag equal to true or not equal to false. Okay, or if flag, how do you write not equal to? Can anyone please tell me how do I write not equal to? In relational operation, not equal to. How do we write equal?
Mark equal sign.
Yes, exclamation equal, not equal to false, right? That means true. Actually, not equal to false means true, right? Okay. So you could say if flag instead of this not equal to false, then still it will work. Okay. Or you see that we have used also counter variable count to count how many times our target variable exists, right? So here actually, so let me go to my C# code. Actually, I have changed here. Okay. So it has actually main code I have with method. So after a week we'll start method. So then you will understand the use of this. But for now we are using this main method. Everything we wrote in main method. So here you see that we use another counter variable, another flag. Like this is not flag, it is called counter variable. So if there is a match, then what did we do? We increase our counter by 1, right? So that then instead of writing this code with flag, what we could do? We could use if count greater than 0, right? That means if there is a match, then we got count at least 1. It's incremented. So instead of using this Boolean flag, we could use this counter. Integer counter. Okay, so we say if counter is greater than 0, or there is another way. Can anyone please tell me what is an alternative way or code I could write here? Instead of if count greater than 0, what else I could write? You see that if I write this, it will work. If count greater than 0, still it will work. So my question is that, is there any alternative statement we can write here?
Greater than or equal to 1.
Yes. So instead of 0, that means even you can say greater or equal to 1. Right? Then it will do something. It will do something. So that means you see that we can write a single line in multiple ways. Okay. Okay. And if count greater equal to 1, then it will execute this, or if otherwise it will execute this. You see that if with if and else statement, if there is only one statement, then using curly brace is optional. So in this case, we have only one statement, right, associated with our else. So or if, then I can, it's optional. So since this is only one statement, even if I do not use this, my program will work. It will work. Okay, has anyone any questions so far? So this code is C#, right? This code is C#. Okay, and as I showed you a minute ago, I have this program written in Java. So just if search for this Java, this is the same code in Java. This is the same program in Java. Okay, but now if we go for C++, so I have same programs written in C++. So in C++, if you go C++, then there is different. Okay. Okay, people who are taking C++ lab, okay, give attention over here. So as you see that in a minute ago, we used this length attribute in Java, and L is in uppercase for C#, but unfortunately C++ does not have this length attribute. So there is another alternative way to find the array size or length of the array by using the size of method. There is a built-in size of method. So by say size of my data, so it will give me size of my data. That means how many bytes it will take the total my data array. So each element will, for integer type, each element will take 4 bytes. So this is 4 byte, this will take another 4 byte, this will take another 4 byte, this will take another 4 byte. So how many bytes it will take? 7 elements, right? 7 times 4, 28 bytes, consecutive memory bytes it will take. So if we divide this size of my data by size of int, so we know that int has a size 4. Then ultimately we will get 7. This is the 7 is my array length or size. So we can use this size in order to check, in order to do something. Okay. So my programs are written in all 3 languages, C++, Java, and C#. So please do some practice. Okay. And has anyone any question about linear search algorithm? If we do not understand linear search algorithm, then you will not understand other searching algorithms or sorting algorithms. This is the foundation of all searching and sorting algorithms. And sorting and sorting algorithms are the foundation of upper level computer science courses. Okay, if you want to take data science, data structure, algorithm, software engineering, any course you want to take, it will be assumed that you understand linear searching and sorting algorithms, all searching, at least some searching and some sorting algorithms. So at this point, anyone has any question? Okay, so If you don't have a question, I have a question for you. Okay. Did you think any limitation of the linear search algorithm? Do you think any limitation? Is there any limitation or disadvantage of linear search algorithm? Did you notice? Yeah, this is my question to everybody. Okay, who can answer this? Did you think any limitation of this linear search algorithm? Yes. Okay, it seems to be slow. In what context? Yes. The problem is that if my array size is a large number, right? If it is a giant array, right? For instance, think about that it is time for census. So in the USA, how many people are there? Or in the whole world, how many people are there, right? So if you want to give one single ID for all people in the USA, then USA has about 331 or 32 million people, right? We need that number of large array. So in order to, in the worst case, in order to search a specific person from the list, it will take long time. Okay. This is really a limitation, right? So there are other algorithms that are more efficient or faster than linear search algorithm. One of these is called binary search algorithm. In the binary search algorithm, we can use the binary search algorithm though if we know that the array is already sorted, array is pre-sorted, then we can use the binary search algorithm. What is mean pre-sorted? What do we mean by sorted? So sorted means there are two kinds of sorting, right? Ascending and descending order, right? Ascending order means starting from smallest element and going to the largest element all the way in. That is called ascending order, okay? And descending, that means starting from the largest element first and go all the way smaller, 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 and the smallest element will be all the way in. So if we know that the array is already sorted, then we can use binary search algorithm. Okay. So you are a native English speaker, and maybe you understand better. But when I was a student like you, okay, we confused about ascending and descending order. Also, I teach my sons how to remember that. And then, so in our country, for instance, we are not a native English speaker. So we use alternative certain. So for instance, we say A. We say A ascending order. Ascending order means from smallest to largest. You see that A, how do we write A? We start with the smallest, right? Pick, right? And over the time it is going expanding, right? It is expanding. It is expanding. So So it was my technique to remember. It's from smallest to largest, and so on. And another is a descending, descending order. So what is descending order? That means we started from largest element, for instance 100, then go 99, and then go all the way 1. How do we remember that? You see D, whenever we type in D, then we start from the large, and eventually it becomes smaller, this diameter. So we used to remember this way, ascending. If you remember one thing, ascending started from smallest to highest, then you will remember descending is alternative way. Okay. So if you know that your data is already sorted, then you can use binary search algorithm. So what happens in binary search algorithm, every time it makes our algorithm data half. It splits our array size to half, and it throws away the another part, unnecessary part. And in this way, it is efficient that it takes only big O of log n times. So if you remember that from your calculus or maybe algebra course, if you remember that, so if we say log 2 up to equal to what? 1, right? Remember this? If we say log 32 equal to, so base 2 equal to log 2 to the power 5 equal to 5 into log 2 up to equal to 5. Right? So if I have 1024 data in my, for instance, if I have 1000 data in my record, then I say log 1024 up to 1024 will take log 2 to the power 10, right? That means equal to 10 times log 2, this means equal to 10. That means it will only take 10 iteration or 10 search to find an element from an array that is sorted array that has maximum 1024 or about 1024 data. So now if you have, for instance, 2048 or 2000 data, then how many times you need to log, you need to search? Can anyone please tell me? For up to 2000 elements in an array. For binary search, how many iteration or search we need? Can anyone please tell me? Remember it from algebra? So 2048 equal to 2 to the power 11, right? So that means I need only 11 search. So the binary search algorithm is more efficient than linear search algorithm, but there is a limitation of using or restriction of using binary search algorithm. What is the limitation or restriction? Can anyone please tell me? Yes. Yes, your array must be pre-sorted. Must be sorted, but if you can say that, okay, I will sort my array, that will not helpful, okay, because the efficient, the best sorting algorithm that takes log of n times. So if you have an array that is not sorted, then it will take this amount extra time to sort it. And then when you sort by applying, so spending this amount of time, and then after that you will get this amount time, you will take this amount time for searching, then still it will take more time than big O of n. Big O n it takes only n times, right? This number is greater than, this number is greater than big O n. Big O n it takes only n time, and it has n into log of n. So it will not work if your data is not sorted already. It will not be efficient. Okay. So let us see. For instance, I have an array 32 elements, and let us see how the binary search algorithm it works. Okay, for instance, let us assume that I have an array of 32 elements. So what I can do, and we are assuming that our elements are already sorted, right? Our elements are already sorted. For instance, here I have data like, for instance, let us assume that this is our midpoint. I have 1, 2, 3, 4, 5, 6, 7, 8, 16 up to 16 here. And I have 17, 18, 19, 20, blah, 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 25 last element. Okay. And so, for instance, this is our midpoint, right? Midpoint. So, we already know that our array is sorted. So the binary search algorithm, it applies it find the midpoint. So if it's an array, so we know that this index is 0, right? And this index will be 31, right? For the areas of size 32. So then we can find the mid. Okay, mid will be the mid, we can find the mid, and then we can say mid will be 0 plus 31 divided by 2. It is an integer division. So result will be 15, not 15.05. Apparently it says 15, right? 15.5, right? But it will give us integer division will give us 15. So that means it will point this element if it is the middle element. Okay, or if it is, we are lucky enough, we find our target element of the middle, then we got it. If it does not do mass, right? So then we will see, for instance, our element 10. So then we will obviously know that our elements exist in the left side, right? 10 is less than 15. Okay, if our element is less than mid element, then we will throw this part out. We do not need to check this part again, because we know for sure that our elements exist in this side, right? So how do we throw that part in our programming concept? So this was our low index, and this was our high index, and this is our mid index. So we can say our high equal to mid. Okay, I'm coming the algorithm first, but let us see soon. But let us see how do we split it. So if we know that our data exists in the left side, then we will throw out the right side, right half, and we will make another split half. And now we will be able to see, is my value on the left side or right side? Is my value is greater than the left side or less than the right side? Since all the elements are sorted, we will be able to find that. How can we find that? By looking the middle element. Because all elements in the left side are less than the middle element, and all elements on the right side are greater than the middle element, right? So every time. So then we will make another split, and then we will keep either this part or this part. Let us see that we got our 10 here in this part. Then we will go another split and another split. So how many total split we got it? 1, 2, 3, 4, and 5. So within 5 split, we will get our expected value. So obviously we will find it if it does exist, and we can claim that it does not exist if there is no match. So you can say 2 to the power 5 equal to 32, right? We know that 2 to the power equal to 5 equal to 32. So it will take log 2 32 equal to log 2 to the power 5 equal to 5 times log 2 of 2 equal to 5 times 1 equal to 5. So we know that log e of a equal to 1 follows. This is the formula. In your math, from your math course, you should remember this. So for 32 elements, we need 5 searches. Whereas in the linear search algorithm, how many iterations we would need? 32. All n, right? Here n equal to 32, right? This is my n. This is my n. So in the linear search algorithm, it takes, in the worst case, n iterations. But in the binary search algorithm, it takes log 2n element iterations. So it is more efficient, right? Now you see that only 5 stops because of this. Now, if I have an array of sorted array of 4 billion sorted numbers, then how many searching we need? Only 32 search iteration I need. Okay, now I have a quick question. So what is US population, total population now? It says Wikipedia says 331 million and some, right? That means 332 million people, right? So if the census database has all people's record sorted, right? Then how many iterations we need to search a specific person record from the census database using binary search algorithm? That means we need to find log 2 of 332 million. So it's about how many? It's around 28. It's around 28 iterations we need. But whereas in a linear search algorithm, how many iterations we need? Exactly this number of iterations we need for linear search algorithm. So that means we understand that our linear search algorithm, our binary search algorithm is way better in some cases than our linear search algorithm, right? But there is a restriction that we cannot use the binary search algorithm for all arrays or all lists. We can use that if and only if the array is already sorted. So this is a quiz question, possible quiz question, okay? So now, do you understand the difference between the linear search and binary search? So people who are online, yes, please. Okay, I see 42 people. I see good. So, but do you understand? Do you remember the concept or difference between a binary search and a linear search? So everybody is online, is muted. No one can speak out.
I understand.
Okay, tell me the difference between a binary search and linear search, please.
Linear search will search each thing in order, and a binary search will cut it in half until it is found.
Okay, thank you. Yeah, that is the thing, right? So now let us see the binary search algorithm. Binary search algorithm is completely different than linear search algorithm. Okay, we found a completely different algorithm. So what we have found here, you see that every time we are splitting our array, right? For instance, if our array is G and if we have a target value, for instance any value, and then initially we start with low equal to 0, mid equal to 0, and high as the number of the elements in G. Okay, for instance, if my, let us draw it, okay? So give attention please, okay? So if this is my this is my G, okay, array G, okay, the entire thing. So how many elements it has? For instance, let us consider that with the previous example, it has 32 elements. So the index will be 0, right? That's starting from 0, 1, 2, 3, and all the way, some element will be 15 over here, some element index will be 16, right here, and then 16 will be here, and other, and all the way I have 17 elements. And what will be the index of the last element? Who can speak out? What will be the index of this element? Yeah, for instance, we have some variable values over here. So 0, 0, 1, 2, 3, 2, 3, 5, 7, maybe 10, or 12, or 13, or 15, or 17. What will be the last, any value it will have? For instance, the last value, I have 25. But all these values are sorted, right? Okay, what will be the index of this? I'm asking about the index. So this is the index 0. All arrays start with index 0. So if my array size, array length is 32, so the index start with 0. So what will be the last index? Who can tell me? What will be this value? Is 32 or 30 or 31 or 33?
31.
Thank you. It will be 31, right? So 0 to 31. So that means 32, right? So initially we are making our low. So we say low, this one is our low. We say low equal to 0, and we say high equal to, so you say we can say last index high equal to, or we can say high equal to, maybe we can say 31 or 32. Sorry, so in this case the number of element of this array. So here 32, right? So then we will find mid. So how can I find mid? So mid equal to low plus high divided by 2. Okay. So here mid will be my low equal to 0, right? Plus high, if we consider high equal to 32, divided by 2. This is integer number, so I will have 16. This index, that means it will indicate this index, 16, this index. So that value, so later we will say value, this is the value at midpoint. Okay, so this means is the value at the middle index. So that means this is this value. Actually, the middle index, it will get 12. This is the value. Okay, or in some algorithms there is a little bit variation. Instead of high equal to 32, yeah, 32, if we consider high equal to the highest index is 31. In that case, we will see that mid will be 0 plus 31 divided by integer division by 2. It will get 15. Actually, it is 15.5, but since we are doing integer division, so that means it will get 15, not 15 point something. In that case, your mid value will be this value. It doesn't matter. It works in both ways. Either way, you can do mid equal to like this or this, whatever you say, it will work. So what we are doing over here in the algorithm, we are checking if our target value equal to our mid value. If our mid value, we are getting mid value here, then we say is found, right? We got it. Otherwise, if we see our target value is less than this mid value, less than. If it is less than that, we need to consider only this part, right? We do not need to consider this part. So if our target value is less than, if our target value is less than mid value, then we don't need to consider the right part. So that how do we get rid of the right part? Just a single change. We can say high equal to mid. That means we no need to consider this part. We jump our high to this part, this position. This is the way to get rid of or throw out the upper part. We will just update our height, because then we don't need, this is the highest point we need to come in, right? We don't need to go the right part. Otherwise, if we know that our target value is greater than this part, this middle value, then we will consider only this part, right? In that case, what we will do? We will update our low value to middle. Otherwise, we say low equal to mid. So this highlighted part is the main body of the binary search algorithm. Okay, I'm taking 5 minutes break, and I'm giving you, everybody, try to understand this code, this pseudocode, and this algorithm. Okay, and then let us check, or I will revisit totally from the beginning if you do not understand. But in order to understand higher level programming in computer science, in order to be a computer scientist or software engineer or anything, you must have clear understanding about this. There is no way that you will have any superficial idea. The good way that I like you to write this algorithm 4 or 5 times on a piece of paper. Okay. Then ultimately you will be able to understand what is happening here. Then if you understand this code, how what is happening, then programming is easy, right? Converting this code in a programming language, if you understand the pseudocode, at this point it is not a big deal, right? So I'm taking a 5 minutes break, and then I will come back in 5 minutes and I will ask you if anyone has any problem in understanding this. Okay, I'm back here. So has anyone any question? Let me see how many people are there. So I see 42 people and there are 8 over here. 100 people, right? 50%. So has anyone any question about these two sorting algorithms, searching algorithm, linear search and binary search algorithm? This process. Anyone has any question? Okay, if you don't have any question, then if you go to my Replit account and search for binary search, example 1 CPP, I have both in all 3 languages. Okay, so in all 3 languages I have this code. Okay, see multiple binary search algorithm in one way, another way binary search too. Okay, I have multiple ways. Okay. How to do the binary search algorithm? Let us see the C++ program, right? For instance, this is my data, is my array name, and it has some elements. I don't need to count manually how many elements are there, right? So in Java and C#, we did have a length attribute that could be used. This array my data dot length in order to find the length of this array, but unfortunately C++ does not have that length attribute. So what we can do in C++, we can say we can find size or length, whatever you say, by doing this. If you say size of my data will take the total size of this array. So every element integer type will take 4 bytes, 4 consecutive bytes. So this is 4 consecutive bytes, this is another 4 bytes, 8, 12, 16, 20, 24, 28, 32. So for 8 elements, it will take 32 consecutive bytes. So then how can I find the size? We can say size of my data, that it will give us 32. And if we divide by size of int or 4, we know that integer size has size 4. Okay. So if we go to Java data types and range, you see that integer type, it takes 4 bytes. Right? So we can say we can divide by 4. Divide by 4, we could say size of int, same thing. Okay, whatever you say, no problem. Okay, so C++ people, for now, just remember this. You can memorize this or remember this. Okay, and then what you are doing, for instance, let us assume that our target is 5. So initially we will say found or flag equal to false. and we'll say low equal to 0 and high will be size. Easy. So we can say size or size minus 1, no problem. It will work in both cases. Let us use size. Okay, and mid initially 0, then say while not found. Until I find, right? So mid equal to low plus high by 2. And if we say if our target equal to my data mid, the data at the position of mid in this array, then we will say the element is found. And we say found equal to true. Otherwise, else if my data is on the left side of my array. How do I say the left side? If my data target is less than the my data of made. So that means here, if in the left side, if it exists in the left side, then what we will do? I will shrink this array by changing the high by mid. So that means I do not need to go beyond the midpoint. Okay, so that means what we are doing over here, high equal to mid. This is the trick that how do we get rid of one part, half of this array. Otherwise, else, that means my data, if it is not at the middle, if it is not in the left side, then it must be in the right side, right? You understand here? So first we are checking whether it is in the middle. If it is middle, then I'm lucky I got it, right? And if it is not middle, then there are two possibilities. One, it may be on the left side, another it may be on the right side. So if we check it is in the left side, then what we'll do, we will shape the high to here, to middle. We say high equal to middle. Okay, so we will make the high equal to middle. Otherwise, if my value, target value is greater than midpoint, then that is in this side, right? In that case, what we will do, I will change my low value. I do not need to check the left side. So I will go jump from my low from here to here. So I will say low equal to mid. Okay. Then how long I will go through? At certain point, I will see if we say if low is greater or equal to high minus 1. Okay, this is one way, another way you can see. Then we say the element is not found. It is little bit tricky. The linear search algorithm is easy, but this is a little bit tricky. Okay, so I like everybody to practice this. Okay, so in my program, so in my Replit account, if you search for binary search algorithm in CPP, you will get on program. It says C#. You will get same program in written in C# language. Okay, and if you search it for Java, you will get another program in Java. So instead of C#, if you search for Java, then I have same program written. Okay, so you see that I have written in two ways, both length minus 1 and both equal to length. So you can implement both ways. You can use either way. There are two algorithms I implemented, binary search 1 and binary search 2. It both works, but the concept is same or pretty identical. Okay? They're a little bit different. So I like everybody to practice this before we come to our next lecture. I like everybody to practice this and can have clear understanding about linear search and binary search algorithm. These are the foundation of even sorting and other higher level of many algorithms. Okay, there is no way that you can skip it. In your test, you will be asked either linear search or binary search. You don't know yet which one will be asked. So has anyone any question? So I'm giving you at least two more problems today to practice. And before you come to your next lecture, everybody please practice these two programs, linear search and binary search. If you do not even understand, try to write this code, this pseudocode, a number of times, 2, 3, 4 times. I think then we will be able to understand this concept. And then, if you understand this, in our next lecture, we will discuss sorting algorithm. But again, the searching algorithm is the foundation of many other algorithms, like sorting algorithms as well as. So you must understand the searching algorithms. Has anyone any question? Okay, your test grade will be published maybe today or tomorrow. So people who are online, has anyone any question?
I think we're good.
Okay, that's good. So thank you so much, and you have a good evening.